Dr. Benny, I have been practicing how to write the laws of mass action problems in the book, and I got most of them correct. But for this reaction, one carbon dioxide gas molecule reacts with carbon solid yield 2 carbon monoxide gas molecules. My equilibrium expression is the equilibrium concentration of carbon monoxide squared over the equilibrium concentration of carbon dioxide times the equilibrium concentration of carbon solid. The answer in the book said my answer is incorrect. I could not figure it out why. Would you explain it to me? Of course, Benjamin. Thank you for setting the stage for me to the next topic. I guess you got all the correct answer when you were given homogeneous reactions. When dealing with heterogeneous reactions involving solids and/or pure liquids, we actually omit them from our equilibrium expression because the concentration of solid or a pure liquid equals its density divided by its molar mass. The density and molar mass of a pure liquid or solids are the same regardless of how much pure liquid or solid is present. We may also look at this idea from a different perspective. As we increase the amount of solid or a pure liquid, we are also increasing the mole and the volume by a proportional amount. Therefore, the concentration of solid and a pure liquid is constant. We treat them as one and exclude them from our equilibrium expression or law of mass action. So, using the example you gave me, one carbon dioxide gas molecule reacts with carbon solid to produce 2 carbon monoxide molecules. The law of mass action is going to be the concentration of carbon monoxide raised to the second power divided by the concentration of carbon dioxide raised to the first power. Again, the exponent will be determined by its coefficient. Since the other reactant is carbon solid and its concentration is equal to 1, it is not in the equilibrium expression. Can you write the equilibrium expression for the decomposition reaction of hydrogen peroxide? I think so. Let me try. First, I'm going to check if the given chemical reaction is balanced. 2 hydrogen peroxide molecules decompose into an oxygen molecule and 2 water molecules. For the numerator of the law of mass action, I will have only the concentration of oxygen gas because water is a pure liquid and it is omitted in the equilibrium expression. For the denominator of the law of mass action, I will have the concentration of hydrogen peroxide squared because the stoichiometric coefficient of hydrogen peroxide is 2. Correct, Benjamin. I think you have a good understanding of the topic now. Just to recap, when we write the law of mass action, we include chemical species in the gas phase and aqueous phase, but omit those in solids and pure liquids. Thank you, Dr. Benny.